Hello students, welcome to the amazing platform of Physics Wallah. Welcome to the PW English channel, my dear students. I hope all of you are excited because today we are going to start the lecture 6 of electrochemistry. Today we are going to discuss a lot of things which would be very easy for you now, my dear students. So let's start the amazing session. Let's see what all topics are we going to cover. So we will be covering conductance today and we'll be doing a lot of practice questions. So let's start this session, my dear students. So before starting this session, I hope all of you remember that when we started this chapter, I told you that basically we will be studying electrochemistry in two major parts, right? Yes. We will be studying electrochemistry in two major parts. One was conductance and the other was your electrolytic cells. And then we covered these electrolytic cells as galvanic cell and electrolytic cell. This is electrochemical cell. I am sorry, this is electrochemical cells. Yes. Perfect. So now, my dear students, I just want to tell you that we have covered this particular part and I told you this is the major conceptual part. When we will be studying this conductance part, this would be super easy. You just need to know a few of the formulas and then you're good to go. You only have to practice the questions. So today is that time that we have reached the conductance part. That is the easy part. We have covered the conceptual part and all of you have understood each and everything. That is amazing, right? Yes. So now today we will be covering the conductance part. So before starting this part, my dear students, I just want to know that if I ask you what are charge carriers, so what will be the answer that comes to your mind? So let's start about charge carriers. Let's discuss about charge carriers. Right? Yes, perfect. Basically, charge carriers are majorly of two types, my dear students. One is your free electrons and the other is free ions. I hope all of you remember when we studied the galvanic cell. When we studied the galvanic cell, the best example you can get is from the galvanic cell. When we studied the galvanic cell, I told you that you have this kind of two electrodes. Yes, and here you have electrodes. I hope everyone remembers this. Yes, ma'am. And then, my dear students, we said that here is your electrolytic solution. Here is your electrolytic solution. You connected these two electrodes with a salt bridge. Right, this was a salt bridge, and if you talk about this particular part, you connected it like this and you said that the electrons flow through this circuit. Okay, I hope all of you remember that we said that the charge is carried by the electrons outside the cell. If you talk about inside the cell, how is the charge carried? By the free ions, right? Yes, and always transfer of electron takes place. Always and always transfer of electron takes place at the surface of electrode, be it reduction, be it oxidation, be it loss of electron at the anode or gain of electron at the cathode. Every transfer of electron will take place at the surface of electrode, right? Yes. And when you talk about the movement of charge in the solution, you need free ions. You need free ions. So I hope all of you remember this, and that is the best explanation that charge can be carried by two major things. One is your free electrons and one is the free ions. If you have electrons but they are not free, then they cannot carry the charge, right? Yes. So you majorly need free electrons or free ions to carry the charge. Why am I discussing this today? Because we will be studying everything about charge movement. Okay, so now, my dear students, I hope you're clear with this. If you want to write it, then write it and then we'll move forward. Pause the video, write it, and then we'll move forward. Okay, so now we can start our discussion. What are we going to majorly discussed today. So now, my dear students, I hope all of you remember that we have been discussing about the electrolytic cell, right? Yes. So first, let's draw the electrolytic cell and understand everything. So I am drawing an electrolytic cell here. I need a straight line. Okay. Okay. So this is your straight line. Now, my dear students, you have electrodes here. You have electrode here. Perfect. And this is your electrolytic solution. Let's say this is your electrolytic solution. I hope everyone is clear with this now. Now, my dear students, we will be discussing a few terms which you might have studied in physics as well. So you will not get any, you will not face any problem in understanding those concepts. If I talk about the resistance here, my dear students, the first word that we will be talking about is resistance. What is resistance? I hope everyone knows the basic definition of resistance. You have studied this in physics. Resistance is the hindrance caused to the flow of charge, right? Yes. So we will say that resistance is denoted by R, and it is the hindrance caused to the flow of charge. Okay, this is the hindrance caused to the flow of charge. I hope this is clear with you. Perfect. Now, my dear students, what I want to tell you is you just need to know this particular formula which you already have studied in physics, and all the other formulas will be derived only on this basis. Okay, so it is very easy. It is very, very easy. See, when we talk about resistance, I hope now what we are actually doing is just see here. Here, my dear students, we consider that these two electrodes are kept at L centimeter distance. That is, they are kept L centimeter apart. Okay. So, if I talk here, then what is L? It is the distance of electrodes. It is the distance of electrodes. Okay. And the area of cross section of your electrodes is A centimeter square. So let us say what is A? It is the cross sectional area of each electrode. Okay. Perfect. I hope you're clear with this. So now, my dear students, if you remember, then we used to say that R, that is your resistance, is directly proportional to the distance between the electrodes. R is directly proportional to the distance between the electrodes. And my dear students, your R is inversely proportional to the area of cross section. R is inversely proportional to the area of cross section of electrodes, right? Yes. So we can say that R is equal to, when we now we'll add these two, this will be R is directly proportional to L upon A. And when we remove this proportionality, we add a proportionality constant, and that constant is R is equal to rho L upon A. R is equal to rho L upon A. So this is the required expression, and I don't think so you have any issue in deriving this expression. Everyone knows that resistance is equal to rho L upon A, where, my dear students, your rho is, let me just tell you what is rho. Rho is the resistivity. This is defined as resistivity. Okay. Yes. Perfect. I hope you're clear till now. Till now, we have only discussed the things which we already know how to calculate the resistance. Resistance is given as R is equal to rho L upon A, where rho is the resistivity, L is the distance between the electrodes, and A is the area of cross section. A is the area of cross section. Now, my dear students, one important thing that we will be considering this in centimeter and this in centimeter square. Okay, always remember that we will be using them in centimeter and centimeter square. Perfect. I hope you're clear with this. Now we need to know the units of resistance. Again, units are very important because every question, every numerical needs the importance, needs you to have the understand the importance of your unit. Unit conversion is the major role in these numericals. Okay, so let's talk about the units of resistance. units of our resistance are, my dear students, ohm. I hope everyone remembers ohm. Yes, or we could say ohm, right? Yes, these are the two units that you generally use for resistance. I hope you're clear with this. Okay, my dear students, if you want to write it, then write it and then we'll move forward. Okay, I hope you've written it. If you want to write the units of R, you can write it. Now, next that we will be discussing is your resistivity. Now we will be discussing about resistivity. Okay, so let's write the heading as resistivity. Okay, perfect. Now, what is the symbol of resistivity? I hope all of you remember resistivity is given by this. Okay. Also, my dear students, it is known by some few names. Let me tell you, those are specific resistance. Okay, so it is also known by the name of specific resistance. If it is given specific resistance or resistivity, you just have to understand that it is denoting you resistivity, that is your rho. Okay, so now I know I have just derived the expression that R is equal to rho L upon A. So can I find the symbol of resistivity? Can I find the formula of resistivity? Yes, ma'am. Just cross multiply it. This would be equal to RA upon L. This is RA upon L. Okay, so this is the expression for resistivity. So this is the expression for resistivity. Okay, yes. So when, if ever in the numericals you are asked anything about resistivity, you only have to use this formula. I hope all of you know R is the resistance, A is the area of cross section, and L is the distance between the electrodes, right? Yes, perfect. Now the next thing that comes to mind is unit of resistivity. Okay, so now let's talk about units of resistivity. What are the units of resistivity? See, how can you find out the unit? It is very easy. You know that resistance is given by ohm, right? Area of cross section is given by centimeter square and length is given by centimeter. So this will be cancelled. So the unit comes out to be ohm centimeter, or you can say ohm centimeter. So these are the units of resistivity that you will be using. These are the units of resistivity that you will be using. Okay. Always remember, I am giving you the unit of length or area as centimeter and centimeter square. So always try to calculate in centimeter and centimeter square only. Okay. If you are asked in meters, then we'll convert this centimeter into meters, but always the calculations will be done in centimeter length, the distance, and the area of cross section as centimeter square. I hope you're clear with this. If you want to write it, then just write it and then we'll move forward. If we also need to define the resistivity. How can we define resistivity? So first let's define resistivity, my dear students. I'll just put a line here and let's define resistivity. You need not memorize the definition. You can make the definition yourself. You know that resistivity is equal to R L upon A, right? You know this. Now, if you take, my dear students, L as 1 centimeter and area of cross section as 1 centimeter square, then what can you say? You can say that your, what was L? Distance between the electrodes, and what was A? Area of cross section. So resistivity is equal to the resistance offered by an electrolyte when the electrodes are 1 centimeter apart and the area of cross section is 1 centimeter square. Because when they both are equal, you can say that R is equal to rho is equal to resistivity is equal to R. So we can say that resistivity is equal to the, or it is the resistance offered by an electrolyte when electrodes of cross-sectional area 1 centimeter square were kept or are kept 1 centimeter apart. So I just made the definition on my own. You need not memorize it. You just need to understand the definition. See, if you take L and A as 1 and 1 centimeter and 1 centimeter square respectively, you can say that rho will be equal to R. So we can say resistivity is actually the resistance offered when the electrodes are 1 centimeter apart and the area of the cross section of the electrodes is 1 centimeter square. So this would be the definition of your resistivity. So you need not memorize it, just make the definition on your own. Okay, so if you want to write it, just write it and then we'll move forward. Okay, I hope you've paused the video. You've written this now, my dear students. We have discussed about resistance. We have discussed about resistivity. Now we are going to discuss a few more terms such as conductance and conductivity. So let's start this, my dear students. If you talk about, if now we've discussed conductance and resistivity, now we'll be talking about conductance. Okay, so here is conductance. So if we talk about conductance, my dear students, then what is the symbol for conductance? That is the most important thing. You need to understand the symbols of all these factors, and the symbol is G. This is your conductance. Okay, conductance is denoted by G. What is conductance? It is nothing but the reciprocal of your resistance. It is nothing but the reciprocal of your resistance. Okay, so we can say that conductance G is actually equal to 1 upon R. Your conductance G is actually equal to 1 upon R. Okay, yes, perfect, everything is clear. If you know, then you can say that we know R is equal to rho L upon A. Have we written the units here? Yes, we've written the units. Okay, so we know that R is equal to rho L upon A. Let's incorporate this into this. What will happen? You can say G will be equal to 1 upon rho L divided by A. So G will be equal to 1 upon rho A by L, right? Yes, perfect. I hope it is clear with you. So this is the actual expression for your conductance. This is the actual expression for your conductance which you will be using in the numericals. So what is conductance? Conductance is 1 upon rho A by L. 1 upon rho A by L. Easy. Right? Yes, perfect. Now we need to talk about the units of conductance. So let's talk about the units of conductance, my dear students. If you talk about the units of conductance, how can we write the unit? You know that G is equal to 1 upon R, right? We know this, so we can write the unit very easily. We can say that the unit will be ohm inverse. We can say it is ohm inverse, or you could say it is ohm inverse. Or you can also say, my dear students, it is also equal to MHO, which is known as Moho. It is also equal to MHO, which is equal to Moho. So these are the three units that you generally use for conductance. These are the three units that you generally use for conductance. Okay, so you just need to memorize one thing, that conductance is reciprocal of resistance, right? Yes, and R is equal to rho L upon A. You just need to incorporate it and solve the questions. Okay, so this is the basic thing about conductance. If you obviously you want to write it, just pause the video, write it, and then we'll move forward. Okay, perfect. Let's move forward, my dear students. Next thing that we will be discussing is this part is very important, which is your conductivity. So you need to write the heading as conductivity. It is given by K. The conductivity symbol is given by K. So the conductivity symbol is given by K. What is conductivity? Also, my dear students, it is known with a few names which you need to know. The conductivity is also known as specific conductance. Specific conductance. or it is also known as, my dear students, kappa. It is also known by kappa word. Okay, so if ever you see kappa word is given, that means they are giving you the conductivity. Okay, now what is conductivity? Let's talk about this. If you talk about conductivity, then my dear students, conductivity is nothing but reciprocal of your resistivity. The same way your conductance was reciprocal of your resistance, your conductivity is the reciprocal of your resistivity. Okay, so K is equal to 1 upon resistivity. This is the first expression that you need to know. The other expression that we can derive from it is that K is equal to 1 upon, now we know how to find resistivity, right? Yes, I'll just tell you how you can understand. Write the formula R is equal to rho L upon A. What do? Just reciprocate it. This would be equal to 1 upon R. This will be 1 upon rho A by L, right? Yes. So now what can you say? You can say that, ma'am, this was actually equal to the conductance. And ma'am, this is actually equal to conductivity, right? Yes. So from here, my dear students, we can say that G is actually equal to K into A by L. So you can find the K expression, which is equal to G in G L by A, right? Yes. So this is the expression for conductivity. This is the expression for conductivity. Perfect. Yes. So this is the expression that you need to know about the conductivity, which is equal to G. G is your conductance, L is your distance between the electrodes, and A is your cross-sectional area, right? So conductivity or kappa or specific conductance is given by G, L by A. Okay, perfect. I hope you're clear till now. Now let's write the units of conductivity. Okay, so now if we talk about units of conductivity, what will be the unit? Very easy, my dear students. You know that G is for ohm, right? Inverse. So the unit would be ohm, inverse. Length is centimeter, and this is given by centimeter square. So we can say that the unit came out to be ohm inverse centimeter inverse. Okay, this is the first unit. Or, my dear students, you can say ohm inverse centimeter inverse, right? Yes. Or you can say moh centimeter inverse. And there is one more unit which you can use, that is, my dear students, Simon centimeter inverse. And let me tell you, this is the unit that is generally used in the numericals. Okay, so your conductivity can be expressed in any of this unit. It could be ohm inverse centimeter inverse, it could be ohm symbol inverse centimeter inverse, mho inverse centimeter inverse, or Simon centimeter inverse. Okay, so this is the basic thing that you need to understand about conductivity. How to find out the expression and what are the units of conductivity. These are the few things which you need to understand. Rest everything is very easy for you. Okay, so you just pause the video, write it, and then we'll move forward. Okay, so I hope you've written this. I hope you're clear with this. Now let's move forward, my dear students. We have discussed till now resistance, resistivity, conductance, conductivity. Only one more expression is there which you need to understand, and that particular expression is your cell constant. So the next heading that you need to write is cell constant. Okay, so here is the cell constant. Now the question arises, my dear students, what is the symbol for cell constant? So let's write the symbol for cell constant. It is G star. It is given by G star. Okay, so your cell constant is given by G star. Okay, what is cell constant? Let's first define a cell constant because it is a new expression. So what is cell constant? Cell constant is the ratio of distance of electrodes to the area of cross-section of electrodes. So this is what you need to understand about about cell constant. What is cell constant? It is nothing but the ratio of the distance of electrodes to the area of cross section of the electrodes. So this means that your G star, that is your cell constant, is actually equal to L upon A. It is actually equal to L upon A. Okay, perfect, ma'am. It is very easy, very easy. We have found the formula for cell constant. Now let's write the units of cell constant. So the units of cell constant will be equal to, my dear students, you know that this is centimeter and area of cross section centimeter square. So the units will be centimeter inverse. So always and always the unit for cell constant is centimeter inverse. It is a centimeter inverse. Whenever you're given any value with centimeter inverse unit, you just need to see and mark that it is your cell constant. Okay, perfect. Now I want to make you understand where this actually is used. Okay, so we just calculated, I hope all of you remember that we calculated 1 upon r was equal to 1 upon rho 1 upon rho into, we just derived it, just let me see, 1 upon r is equal to 1 upon rho A by L, right? It was A by L. I hope you remember this, right? So you know this, my dear students. This is your conductance G, this is your conductivity K, right? Yes. Now we'll just use this. Okay, see, from here we can say that conductivity is equal to G, conductivity is equal to G into A by L. I hope it is clear. Just a second. Sorry, conductance is equal to conductivity into A by L. Right? Now what are we going to do? We are going to write the expression for K. This will be G into L by A. G into L by A. And from here, you need to understand that this L by A is your G star. This L by A is your G star. So from here, you get the expression that conductivity is equal to G into G star. Conductivity is equal to G into G star. This is a very important formula which is asked a lot of times, that your conductivity is actually equal to the conductance into the cell constant. How do you derive this? You just write 1 upon r is equal to 1 upon rho A by L. You know that this is equal to G, so G, this is equal to K, so K, A by L. Just cross multiply it and you will get the expression that conductivity is equal to G into G star. Right? Yes, I hope you're clear till now. You can pause the video, write it, and then we'll move forward. I hope you've written it, right? Yes. Now my dear students, I'll just make you understand, revise everything, and you will see that whatever we have studied till now, you only needed one formula to memorize and other things were very easy. Okay, so the formula that you wanted, I'll write the heading as revision. So now, my dear students, see, you only need to know the formula R is equal to rho L by A. This is the formula which you need to understand. Everything is very easy. How? See, R is equal to rho L upon A. This is the formula we know. We know how to find out the value of R, how to find out resistivity. This will be R A by L. Okay. So, two expressions we have found out. Now, let's talk about the conductance. If we talk about conductance, then conductance G is equal to 1 upon R. So, this will be equal to 1 upon resistivity, and this would be A by L. So, ma'am, this is the expression for conductance. Let's talk about conductivity. Conductivity is given by K, and this is equal to 1 upon resistivity. And this will be equal to, if you talk about 1 upon resistivity, this will be equal to G into L by A. G into L by A. I hope you're clear with this. Also, you know that this particular expression is your cell constant. L by A is your cell constant. So, K is equal to G into G star, right? Yes, see, you have just derived all the formulas just in the matter of 10 or 12 seconds, right? Yes. So only this formula is to be known. Every formula you can derive on your own, right? Yes, only this was the thing that you needed to understand. Now you have to solve the numericals. So easy, right? Yes. So if you want to pause, you want to write, you can write, and then we'll solve a few numericals. Let's solve a few numericals. Okay, so now here is a question, my dear students. Just pause the video, try the question yourself, and then see ma'am's approach. You are given that if K, that is your conductivity, is given as 1.2 into 10 raised to the power minus 2 Simon centimeter inverse. You can just check the unit and you can understand what is given to you. Now, if conductivity is given to be, if your K is given to be 1.2 into 10 raised to the power minus 2, right? Yes. And resistance R is given as 60 ohm. Then find G star. You have to find the cell constant. Okay. I know that conductivity K is equal to G into G star. We have to find G star. See, you know that conductivity is equal to G into G star, right? Also, my dear students, you know that your conductance is equal to 1 upon R. So, I can write this expression as K is equal to 1 upon R into G star. So, what will be G star equal to? It will be equal to R into K. What is R value given? It is given 60. And what is your K value given? 1.2 into 10 raised to the power minus 2. Just multiply it, you will get your G star. And my dear students, what is the unit of cell constant? It is centimeter inverse. So the unit would be centimeter inverse. Easy. This is how you solve the numericals. Just write down what is given to you and accordingly write the formula, modify the formula and solve the question yourself. Okay. Perfect. I hope you're clear with this. You can pause the video, you can write it yourself, and then we'll move forward. Okay, I hope you've written it. Now let's move forward to the next question. The next question, pause the video, try the question yourself. Pause the video, try the question yourself. The question says a conductance cell was filled with 0.02 molar KCl solution which has conductivity. Now you are given the conductivity, that is K value, to be 2 into 10 raised to the power minus 3. And the resistance when what? A conducting cell was filled with 0.02 molar KCl solution which has a conductivity of this. Find the resistance. So basically you have to find the resistance and you are given sigma equal to how much? 0.1 centimeter inverse. Now, the first question that will come to your mind is, ma'am, what is sigma? We haven't studied sigma. If you come across any such symbol which you haven't seen, just see the unit. If you see the unit, it is centimeter inverse. And which term has this unit? It is cell constant. So this means that they are giving you this as your G star. Okay, this is your cell constant. So now we can find out everything out. We know that conductivity is equal to G into G star. I also know that G is equal to 1 upon R. So conductivity is equal to 1 upon R into G star. I need to calculate R. So R will be equal to G star upon conductivity. What is G star value? 0.1. And what is your conductivity value? 2 into 10 raised to the power minus 3. Right? Yes. This will be equal to 0.1 into 10 raised to the power 3 upon 2, which is equal to 100 upon 2, which is equal to 50. And resistance, so the unit will be of ohm. So 50 ohm will be your correct answer. This is how you solve numericals. So easy, right? Yes, you just need to understand what is given to you and you need to put it in the formula. Okay, yes, I hope you're clear with this. You can pause the video, write it, and then we'll move forward. Okay, my dear students, I hope you've written this. Now let's move forward and try to learn a new word. Let's try to learn a new word, which is your molar conductivity. Molar conductivity, my dear students, symbol is given by lambda m. What is molar conductivity? Is the conductivity offered by 1 mole of your electrolyte. So first let's write it. It is the conductivity one mole of electrolyte. Okay, I hope you're clear with this. Which 1 mole of electrolyte? Initially we studied this, my dear students, and you know that this is your electrolyte. This, when you have 1 mole of electrolyte, then what is the conductivity offered is known as molar conductivity, right? Yes. So now for molar conductivity, you only and only need to understand the formula. Okay, you only need to know the formula, my dear students. So your molar conductivity, which is given by lambda m, is given by K into 1000 upon molarity. This is the expression for molar conductivity. Now let's understand each and every term here. Okay, what does lambda m stand here? Lambda m is your molar conductivity. Okay, what is K here, my dear students? This is your normal conductivity. Kappa, this is your conductivity or your kappa, right? Yes, and this is always given in Simon centimeter inverse. If you talk about m is your molarity, which we have studied, right? Molarity is given in moles per liter. Molarity is always given in moles per liter. Okay, so this is the expression for your molar conductivity. I hope you're clear. Perfect. Now we'll be writing the units for molar conductivity. It is, my dear students, Simon centimeter square mole inverse. Simon centimeter square mole inverse. This is the unit for molar conductivity, which is Simon centimeter square mole inverse. If you are given your conductivity in if it is given in Simon meter square mole inverse, then you just need to convert the centimeter into meter. Okay, so I'll tell you the conversion as well, don't worry, but you need to understand that always and always the calculations will be done in this particular unit. Okay, perfect. Very good, my dear students. I hope you're clear with this. You can pause the video, write it, and then we'll move forward. Just pause the video, write, and then we'll move forward. I hope you've written it. Now we will be talking about equivalent conductivity. The same way we discussed the molar conductivity, equivalent conductivity is the conductivity offered by the one equivalent of your electrolyte. So it is the conductivity offered by one equivalent of electrolyte. Perfect. Now the expression for equivalent conductivity is again very similar. Equivalent conductivity will be equal to K into 1000, and the change here would be upon normality. N is your normality. Okay, so now let's write what each factor denotes here. Lambda equivalent is the equivalent conductivity. Your K is the normal conductivity. And your N is the normality. Equivalent per liter. Equivalence per liter. Okay, yes. And again, my dear students, if you talk about the units of equivalent conductivity, it is Simon centimeter square equivalent inverse. Simon centimeter square equivalent inverse. Okay, yes, these are the few things which you need to understand. What is the expression? What are the units that we generally express it in? Now I will be telling you that what if you are given some unit in centimeter or you are asked in meters, how to interconvert them. Now we will be discussing that. Pause the video, write it, and then we'll move forward. I hope you've written it. Now, let's talk about the conversion. Let's talk about the conversion. So now, my dear students, what happens in conversion is, let us say you are given 2 Simon centimeter square mole inverse. Okay. Now you have to convert it into 2 meter square 2 meter square mole inverse. So how will you be doing that? So now, my dear students, for this you just need to understand that we know 1 centimeter is equal to 10 raised to the power minus 2 meters. Okay, use this particular part and you're good to go. You know that 2 Simon centimeter square, and you will have mole here, right? Yes. Okay, perfect. Perfect. Simon centimeter square mole inverse. Now you know that this will be equal to 2 into Simon. Now see, you have 1 centimeter. 1 centimeter is equal to 10 raised to the power minus 2 meters. So 10 raised to the power minus 2 whole square. This will be meter square, and here it will be mole, right? So you can say this is equal to 2 into 10 raised to the power minus 4 Simon meter square mole inverse. So this is how you will be converting them. This is how you will be converting them. You can pause the video, write it, and then we'll move forward. I hope you've written it. Now we can move forward. Now you only need to know this. Okay, so now you were given 2 Simon centimeter square mole inverse and you needed to convert it into meter square. You did convert it. Now, what if the question comes, somehow the question comes that you have, let us say, 10 Simon meter square mole inverse, and you have to convert it into Simon. So how will you convert Simon centimeter square? How will you convert it? You know that 1 centimeter is equal to 10 raised to the power minus 2 meters. So 1 meter will be equal to 10 raised to the power minus 2 centimeter square centimeter, right? Just use this part in this. You have 10 Simon meter square mole inverse. So can I say mole inverse would be Simon meter square and mole would come out here. This would be 10 Simon, and my dear students, 1 meter is equal to 10 raised to the power minus 2 centimeters, and you have square of it, so 10 raised to the power minus 2 whole square, and this would be centimeter square upon mole. So this would be 10 into 10 raised to the power minus 4 centimeter square mole inverse. So this would be 10 raised to the power minus 3 Simon centimeter square mole inverse, right? Yes. So this is how you will be converting them. This is how you will be converting them, right? Yes. Let me check. 1 meter is equal to, okay, ma'am did a mistake. Just a second, my dear students. See what I did. You have 1 centimeter here. So 1 meter would be equal to 10 raised to the power 2 centimeters. Now, yes, ma'am. Yes. Okay. So now you have 10 Simon meter square mole inverse. So mole will come out to be here. So this would be 10 Simon. 1 meter is equal to 100 centimeters. So whole square centimeter square upon mole. So you can say that this is equal to 10 into 10 raised to the power 4 Simon centimeter square mole inverse, right? Yes. So 10 raised to the power 5 Simon centimeter square mole inverse, right? Yes. So this is how you solve the questions. You just need to know the expression and then solve the question. Okay. Yes. I hope you have understood how to convert them. So you can pause the video, write it, and then we'll move forward. Okay, perfect. Now, the other thing that we need to understand is we need to know the expression, the relationship between molar conductivity and equivalent conductivity. For deriving the expression, the relationship between molar conductivity and equivalent conductivity, we need to know about molarity and normality. Though this is a part of your mole concept chapter, but I know a lot of you are confused or might have forgotten. So now I am here to help you out. Okay, so I know that molarity is equal to moles. Can I say moles as N by volume in liters? Okay, so molarity is equal to moles divided by the volume of the solution in liters. I know that normality is equal to equivalence upon volume in liters, right? Yes. Now we need to understand what is the relationship between molarity and normality. I'm taking you from the start to the end, so try to understand it. Okay, so now you know that, my dear students, know that moles is given by given mass divided by the molar mass. You also need to understand that equivalents are given by given mass by the equivalent mass. What is equivalent mass? Your equivalent mass is actually equal to the molar mass upon n factor. Molar mass upon n factor. So now what are we going to do? We are going to incorporate it into this particular expression. So ma'am, equivalence will be equal to given mass upon molar mass divided by the n factor. So n factor will come out to be here. I hope you're clear, right? Yes. Now just see my dear students, this particular part is actually equal to the number of moles. So I have derived an expression between the equivalence and moles. Ma'am, equivalence is equal to number of moles into the n factor. This was the first expression that you need to understand how to find out the relationship between equivalence and moles. Your equivalent is always equal to the number of moles into the n factor. I have told you everything how I have derived. I have derived equivalent mass. Equivalent mass is molar mass by n factor. Equivalence is equal to this. I have given you everything. Now you're clear with this. Now you have equivalence here. Now my dear students, you know that normality is equal to equivalence upon volume in liters. Equivalent is equal to n factor, moles into n factor. So normality is equal to moles into, this would be equal to moles into n factor upon the volume. Now, can you see this expression? What is this equal to? Molarity. So you found out the relationship as normality is equal to molarity into n factor. I gave you each and every step to make you understand this particular expression. This is the most important expression which you should have known because you have studied this in your mole concept. Okay. Yes. So I hope you're clear how normality is equal to molarity into n factor. What we needed to find out, we haven't calculated it till yet. We have only found out this. These two expressions were important to derive that expression. Okay, so if you know this, then you can say we know that molar conductivity is K into 1000 upon molarity, and equivalent conductivity is equal to K into 1000 upon normality. I know that normality is equal to molarity into n factor. So now what will I do? I'll write this expression in this. So ma'am, your equivalent conductivity will come out to be K into 1000 upon molarity into n factor. If I see, I can say that this particular expression is actually your molar conductivity. So your equivalent conductivity is equal to molar conductivity upon n factor. Or we can say that molar conductivity is equal to equivalent conductivity into n factor, right? Yes, this was the most important expression that you need to understand. This is the most important expression that you need to understand. I have given you each and every step how I derived this expression so that you will have no confusion. I wrote the formulas. I told you that normality is equal to molarity into n factor. We have derived it. We incorporated that expression here. We know that this is equal to the molar conductivity. So the molar conductivity comes out to be equivalent conductivity into n factor. This is a very important formula which you will be using again and again. So pause the video, write the derivation because this is the most important part. I hope you've written it. You can write this as well. Okay. Now, my dear students, if you have written this, now I will also explain you how you calculate the n factors. Okay, how do you calculate the n factors? So, we will be talking about electrolytes. So, I'll only explain you how to calculate the n factors for electrolytes. Okay, so for calculating the n factors, what you need to do is you just need to see the electrolyte. Just let me see that whether it is getting recorded or not. Yes, it is getting recorded. Okay. So for calculating the n factors, you just need to see the electrolyte. Let's say you have an example. We'll talk about examples. First is your KCl. So this is an electrolyte and you just need to see the total positive charge or the total negative charge for the n factor. Just see in an electrolyte how much is the total positive charge or how much is the total negative charge. If you see in KCl, the total positive charge is +1 and the total negative charge is -1. So the n factor here is 1. I hope you're clear with this. Let's take another example. I'll write all the examples first. Let's take H2. Let's take Na2SO4. then you will have AlCl3, then let's say you have Na3PO4, then let's say you have um, Mg Mg3PO4 whole twice. No, don't write this. Na3PO4, and let's take what or other. Okay, we'll go with these. I hope you will understand these. Okay, now if I have told you that how to calculate the n factor, you just have to see the total positive charge or the total negative charge, you can find the n factor. So see, for Na2SO4, you have total positive charge as 1 Na plus has +1 charge. There are 2 Na, so you will have +1 into 2, total +2 charge. If you talk about total negative charge, you have SO4, 2 negative, so total charge is 2 negative. So the n factor is 2. Similarly, if we talk about AlCl3, Al +3, so it has total +3 charge. 1 Cl has -1 charge. There are 3, so -1 into 3, that is -3. So total negative charge is 3, so n factor is 3. If we talk about Na3PO4, 1 Na has +1, 3 Na are present, so +3. If you talk about PO4 negative, 3 negative charge, so total 3 negative charge. So again the n factor is 3. So this is how you calculate the n factors for the electrolytes. You just check the total positive charge or the total negative charge and you can find out the n factors. Okay, and then you can find out the relationships also. Okay, so now let's solve a few questions. So here is a question for you. You have to try this question yourself. Try the question, my dear students. You have the electrolyte, you have to give the n factor, and then you'll have to give the relationship between the molar conductivity and the equivalent conductivity. We know that molar conductivity is equal to the equivalent conductivity into the n factor. Just use this expression I am giving you again. Okay, try this question. Okay, let's see. Ma'am, Na plus and Cl minus, so the n factor is 1. For BaCl2, I know the total charge is +2 and -2, so n factor is 2. For AlCl3, the total charge is 3. N factor is 3. Fe2SO4 is a little complicated one. You have, my dear students, Fe plus 3 and you have 2, so it will be +6 charge. If you talk about SO4, you have -2 charge on 1. You have 3 of those, so -6 charge. So total N factor here would be 6. So let's write the expression. This would be equal to equivalent conductivity into 1. This would be equal to equivalent conductivity into 2. This would be equal to equivalent conductivity into 3, and this would be equivalent conductivity into 6. So this is how you find out the relationships, and if you know the equivalent conductivity, you can calculate molar conductivity. If you know the molar conductivity, you can calculate the equivalent conductivity, and vice versa. Right? Yes, perfect. Very clear with the concept, I hope. You can pause the video, write it, and then we'll move forward and solve a few questions. Okay, I hope you've written it. Let's solve the questions. The question is on your screen. You have to try the question yourself and then we'll move. And then you have to see ma'am's approach. Okay. The question says the molar conductivity of a 0.054 molar solution of MgCl2 is, you have MgCl2 as electrolyte. First thing. Then you are given the molar conductivity as 200 Simon centimeter square mole inverse. Then what are you given? At 298 Kelvin, a cell with electrodes that are 2 centimeter square. So area of cross-sectional is given to be 2 centimeters square in surface area, and the distance between the electrodes is 0.5 centimeter apart, is filled with MgCl2 solution. Find the conductance. So you have to calculate the G. You have to calculate the conductance. See, I know one thing very clear, that for calculating G is equal to G star, where G is equal to G star is equal to L upon A. L is given to be 0.5 and area is given to be 2. So I can calculate G star. G I have to calculate. Now let's talk about conductivity. How are we going to calculate conductivity? For conductivity, I know molar conductivity is equal to K into 1000 upon molarity. Am I given the molar conductivity? Yes, ma'am, it is 200. What is the conductivity? I have to calculate into 1000. What is the molarity, my dear students? If you see, you are given the molarity, which is 0.04 molar. So this will be 0.04 molar. So K value will be equal to 200 into 0.04 upon 1000. Okay. So now you need to calculate G. G is equal to K upon G star. What is the value of K? I hope you can see. You can say that this is equal to 4 into 2, 8. 8 into 10 raised to the power minus 3. Yes. So, ma'am, K is 8 into 10 raised to the power minus 3 upon 0.5 upon 2. So, 0.5 and this would be 2. So, you have to just solve this and you will get the value of G, right? Yes. So now all the formulas that you have studied are going to be used in different ways. So you just need to modify them, right? Yes. You just need to see what all values you need to know and then you can find out. I hope you're clear with this. I calculated the cell constant from the values given here. Then I also know that I need conductivity. For conductivity, I use this expression. I use the expression, use the value and found out the correct answer. Solve this question and you will get your answer. I hope you're clear with this. Perfect, my dear students. Pause the video, write it, and then we'll move forward. Let's move forward to the next question. What does the next question say? The next question is on your screens now. Just see the question. Question says that the resistance of 0.1 normal. So normality of the solution is to be 0.1 normal. Of the formic acid is 200 ohm. So you are given resistance as 200 ohm. And the cell constant also, my dear students, G star value is given to be 2 centimeter inverse. The equivalent conductivity is, you have to calculate the equivalent conductivity. So for calculating the equivalent conductivity, I know that I need K into 1000 upon C. Sorry, normality. I have the normality here, but I don't have the conductivity. How am I going to calculate the conductivity? Try this. Understand. Try to do this. How will you find out the conductivity? I know that conductivity is equal to G into G star. And what is G? G is 1 upon R into G star. What is resistance? 1 upon 200 is given. And what is the G star value? 2. So 1 upon 100 is your K value, that is your conductivity. So just incorporate it. This will be equal to 1 upon 100 into 1000 upon normality. Normality is 0.1 normal. This will be 10 upon 0.1, which is equal to 100 Simon centimeter square equivalent inverse. So this is the final equivalent conductivity that you have calculated. Okay, so this is how you will be solving questions. They are very easy. You just need to modify the formula as I said. Pause the video, see the question, and then we'll move forward. Okay. Let's solve a few more questions, my dear students. I'll give you a few as your homework as well. So here is the question. The resistance of 0.1 normal solution of formic acid is, okay, we've done this question. We've just done this question. This was equal to be 100. So we just calculated it. Option A is your correct answer. Right? Yes, perfect. Let's move forward to the next question. Next question says, a conductance cell was filled with 0.02 molar KCl solution, which has a specific conductance. Now you are given specific conductance K equal to be 2.768 into 10 raised to the power minus 3. If its resistance is, also you are given the resistance, which is 82.4 ohm. At this, the cell constant is, you just need to give the cell constant. It is the most easiest question because you know that K is equal to G into G star. And what is G? 1 upon R into G star. K. What do you need to calculate? You need to calculate G star. So you can say that G star is equal to K into R. What is K value? 2.768 into 10 raised to the power minus 3. What is the resistance? 82.4. Just multiply it and you will get your value G star. Right? Yes. I hope you're clear with this. Such easy questions are asked and you just have to use the formulas. Okay. Just pause the video, write it, and then we'll move forward. Okay. I hope you're clear with this. Can we move forward to the next question? Okay. The question says that electrolytic conductance is due to the movement of. Why is how electrolytes conduct? See, electrolytes have ions and they conduct in the solution. And how do they conduct in the solution? Through ions, not electrons. So, through free ions or ions. Do we have ions option? Yes, so option B is your correct answer. I hope you're clear with this. Very good, my dear students. Perfect. Let's move forward to the next question. Next question is, molten sodium chloride conducts electricity due to the presence of, again molten NaCl is a electrolyte, and how will it conduct electricity? Due to free ions, right? Yes, so free ions, option B is again your correct answer. Okay. Next question, my dear students. The question says that the relation among conductance, among conductance, that is G, your specific conductance, that is K, and the cell constant is. Is it a typical question? No, ma'am. We know that the relation is conductivity is equal to the conductance into the cell constant. So K is equal to G into G star. So K is equal to G into G star, but you have to give the expression as G. Okay. So G will be equal to K upon G star. K upon G star. Okay. And what is G star? We know that G star is equal to L upon A. So let's write this K upon L upon A. So G is equal to K A by L. Is there any expression K A by L? Yes, ma'am. Option B will be your correct answer. See, it was an easy question, but again, it just complicated it by giving you a more by giving you a more precise formula. Okay, by using the in terms. Okay, I hope you're clear with this. Option B will be your correct answer. Pause the video, you can write it, and then we'll move forward. Okay, so now let's do the next question. Try the question yourself, my dear students. What does the question say? The question says that resistance of a decimolar solution, if you have a decimolar solution, means, my dear students, 10 raised to the power minus 1 molar solution. Okay, these are the few terms which you study in your mole concept in 11th class in the starting, where you have a chart given in your first chapter, deci, centi, nano. You have been given the values of these. So decimolar means this. Okay, so resistance of a decimolar solution between two electrodes 0.02 meter apart. So you are also given length 0.02 meters. This time you are given the value in meters. And 0.0004 so now you have area of cross section as 0.0004 meter square in area was found to be 50 ohm. So your resistance is given as 50 ohm. Okay, so you have to give the specific conductance K. So you have to give the specific conductance K. So I know the specific conductance is given by G into G star, where G is the conductance and this is equal to 1 upon resistance, and G star is L upon A. Let's try to solve. You have resistance as 1 upon 50 and you have length equal to 0.02 meters, divided by you have 0.0004 meters. So let's try this. 1 upon 50 into 2 into 10 raised to the power minus 2 upon 4 into 10 raised to the power minus 4. This would be 1 upon 50 into 2, and here it would be 100. So this would be 100 upon 100, which is equal to 1, right? Yes. Do we have 1? What is the value? We have conductivity. So conductivity is equal to 1 Simon meter inverse. You have conductivity as 1 Simon meter inverse. So 1 Simon meter inverse means option B will be your correct answer. Option B will be your correct answer. So this is how you will be solving these types of questions. I hope you are clear with this. Perfect. Let's move forward to the next question. Okay, I hope we are done with these questions. The no, you have one more question, my dear students. Here is the question. Try this question. What is the question? Let me see if I can give you this as your homework. Resistance of KCl solution in a conductance cell is 300 and the conductivity is this, the value of cell. Yes, my dear students, you can do this question as your homework. So this will be your homework question. Try the question yourself and let me know the answer in the comment section. Okay. Yes, I hope you are clear with this. Perfect, my dear students. With this we end our session. I hope you are crystal clear with each and every part. Today's topic was very easy, very easy to understand, and very scoring as well, because if you can apply the formulas, you can definitely solve the questions and you will get a lot of marks, right? Yes, so try to solve the question, try to gain more confidence by practicing. We'll meet in the next session. Till then, keep studying. All the very best. Thank you so much.